All right, I'm covering 6-9 vertical motion in class, but I'm going to have this video here too in case you need it to go back to. The formula we're going to use is d equals rt minus 5t squared. This is vertical motion, so it's not the horizontal motion you know about from before. It's talking about when something goes up in the air. The subtraction is coming in because the ball has to come back down. When you do d equals rt, you don't really have to worry about that because when you're moving horizontally, you can go on forever, but when you're moving in a vertical way, gravity comes into effect, so you have to move down. So a ball is thrown upward with an initial velocity of 35 meters per second. So the r is this initial velocity. So we're going to fill in r as 35. Okay, so I'm identifying what I know. In letter A, how high is the ball after 3 seconds? Well, 3 seconds is a time, so I'm going to fill in 3 for time. And the distance is what I don't know. There always has to be something you don't know, or else why are you solving it? So I'm going to change this to a red. Okay, so all we're going to do is we have D. I was hoping that would change that to red. Okay, I know my rate is 35. I know my time is 3. And again, the exponents are a little difficult on the Smartboard software. So when I do that, you follow your order of operations. So 35 times 3 is 105 minus 5 times 9, because you do your exponents first. That gives me 105 minus 45, and that gives me 60 meters. Okay, so how high is the ball after 3 seconds? It's 60 meters high. And again, we're describing vertical motion, so the motion like this. It was thrown upwards, it traveled up to a point, and then it came back down. For the next problem, our initial velocity is still 35 meters per second. So again, I'm going to fill in what I know. I know my distance now. My distance is 50 meters. My rate is still 35, but now the time is what I don't know. So again, let's see, I'm going to fill in what I know. So my formula is d equals rt minus 5t squared. You can get that from the other side. So I'm going to fill in 50 for distance, 35 for time, okay? Now, when I look at this, I filled in everything. T is what's left, but you can't solve this like normally because look right here. We have a t squared. My highest exponent on the t is a quadratic. That means that this is a quadratic equation, and I'm going to use one of my methods of solving for quadratics. First step is going to make this equal 0. Now, I'm going to choose to add 5t squared to both sides. This must still be on. I'm going to subtract 35t. So I took this and moved it to the left. I took this and moved it to the left. And then plus 50, because that's still on the left, equals 0. Then you can use your quadratic formula or whatever you want to use. So if I'm using quadratic formula, I'm going to have, let's see, opposite of b, my b is 35, so 35 plus or minus the square root, or this might be easier for me to do with the pen. So 35 plus or minus the square root, because that's negative b, so negative of negative 35. When you type in your b squared, please make sure that your b is in parentheses. We've talked about this with quadratic formula. okay, minus 4a and c all over 2a. Okay. In the interior, you're going to get $225 for your discriminant. So 35 plus or minus the square root of 225 all over 10. And when you solve that, you will get 2 different times. You'll get 5 seconds. And let me check the other one. Make sure I have that. And 2 seconds. And the reason you're getting 2 times, remember, is it is going to reach that height at 2 different times. If this is 60 meters, it's going to hit it at 2 seconds when it's traveling upward. And then it's going to go up, it's going to come back down, it's going to hit 60 meters again at 5 seconds. So it is making sense that the answer is 2 different times because it will be that height once on the way up and once on the way down. This next one is going to be the same idea. I'll set it up. So you'll have 57, because that's my distance, equals 35 minus 5t squared, 35t. Okay, and you'll do the exact same thing you did before. This one just comes out to decimals instead of whole numbers. For the 70 meters, you're going to do the same thing. We're going to have 70, 35, and you'll solve there. With this one, what's going to happen is you're going to get a negative under the square root. That means it never gets that high. It's easier for me to type that. And again, the picture for my visual people, your picture is going to be that this idea of the ball is traveling upwards, there is some height it's not going to reach. So when you solve all this, you plug in 70 for the distance, 35 for the rate, you make it equal 0, and you solve, you will see that the discriminant is negative, and what that means is your answer would be it's never going to reach 70 meters. When will the ball be back to the ground? Remember, we're not talking about the horizontal distance, we're talking about the vertical distance. So when it reaches the ground, which is the idea of where we let it go, how much higher was it than when it started? Here it was 60 meters, 50 meters, that idea. So when it comes down here, when is it back at the ground? When the distance equals 0. So when it says something like that, back at the level it was thrown, you're going to plug in that the distance is 0. Rate is 35. You'll solve for time again. So your equation will look like this. This already equals 0, so you don't have to do that extra step. And you can solve it. And what you should get is 7 seconds. I believe it is. Is that 7? Yeah, 7 seconds. You, again, do quadratic formula. At what time will the ball be at its highest point? Well, you can take any of the 2 times. I'm going to take the initial 2 times we did when it was 60 meters. And it's going to be halfway between those. So this was at 2 seconds and 5 seconds. This is back from problem B. So 5 plus 2 over 2. Because that highest point is going to be halfway between. So it's going to be at its highest point at 3.5 seconds. How high is the ball at its highest point? So again, it's looking for the distance. We don't know this. The rate is still 35. And for your time, you know that. It's right up here at 35 seconds. So, or 3.5 seconds. So you'll plug in 3.5 for the time and you'll solve that equation. The last part that I didn't talk about would be if it says, what happens if it's so many meters below the level it was thrown? If it's somewhere down here, just remember to set the distance equal to a negative number. So if it says when will it be 10 meters below the level it was thrown, you would make distance equals negative 10, and again, you would solve the equations. So you should have these problems in your notes, but I wanted to talk you through at least the setup. If you're having trouble on the solving piece of it, I can help you in class.